Hi, this is P. Srinivasrao. Today we discuss about the topics distance problems, displacement problems, distance and displacement problems. In the previous video, we discussed about distance and displacement concept. Based on that concept, today we discuss about problems. And first one, we discuss about only distance problems. After that, displacement problems. After that, distance and displacement combined problems. So first one, we deal with distance problems. First question, the position time graph for a particle moving along a straight line is shown in the figure. The total distance traveled by it in time t equal to 0 to t is equal to 10 second is. The diagram is given below, and the options are given as first option, that is A 0, and option B 10 meters, option C 20 meters, and option D 80 meters. So to solve this problem, first one, we concentrate on the diagram, and in this diagram from 0 to 2 seconds the object travels 10 meters distance, and from 2 seconds to 8 seconds that object or body is at rest, and from 8 seconds to 10 seconds it returns, and it returns from 10-meter distance to 0. So distance means the length of the path we can calculate, and from 0 to 2 seconds 10-meter distance, and 8 to 10 seconds 10-meter distance. Therefore the total distance is taken as the length of the path, that is equal to 10 plus 10, that is equal to 20 meters. That implies option C is correct. And next one, we come to second question. A drunkard walking in a narrow lane takes 8 steps forward and 6 steps backward, and so on. Each step is 1 meter long and requires 1 second. Determine how long the drunkard takes to fall in a pit 18 meters away from the start, and distance traveled by the drunkard in this situation. So to solve this problem, first one, we follow the diagram. So that diagram is like this, and here at point A drunkard is there, and at point B, that is 18 meters mark, pit is there, and for first 8 seconds he starts from point A to 8-meter mark, and next 6 seconds he travels from 8 meter to 2 meter mark in backwards direction. Next 8 seconds he travels from 2 meter to 10 meter mark in the forward direction. Next 6 seconds he travels from 10 meter mark to 4 meter mark in backwards direction. And next one, in the same way, next 8 seconds he travelled from 4 meter mark to 12 meter mark, and next 6 seconds in backwards direction 12 meter mark to 6 meter mark in backwards direction. Next 8 seconds he travels in the forward direction from 6 meter to 14 meter, and next 6 seconds in backward directions from 14 meter to backward direction, that is 8 meters, and next 8 seconds from 8 meter to 16 meter in forward direction, and next 6 seconds he travel from 16 meter mark to backward direction, that is 10 meters, and next 8 seconds he travel from 10 meter mark to 18 meters. So in that manner finally he reaches the pit. So that is about a diagram. And to find out the total time required, you can add all the times. By adding all the times, you can get the total time is t is equal to 8 plus 6 plus 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 8. T is equal to 8 into 6 plus 6 into 5, that is equal to 48 plus 30, that is equal to 78 seconds. The same way to find out a distance, the process is distance traveled is d is equal to 78 into 1, because each step length is given as 1 meter, therefore d is equal to 78 meters. So that is about question 2. So these two are taken as distance problems. Next one, displacement problems. Question 3. An athlete completes one round of a circular track of radius r in 40 seconds. What will be his displacement at the end of 2 minutes 20 seconds? So here the person is traveling in a circular track. So if the person is traveling in circular track, to find out the displacement, we give one formula in the previous session, that is S is equal to 2r sine theta by 2. And to find out that displacement value, first one we know about angle, and after that radius, and that radius is given as r. So to find out the angle, the given data we can use. From the given data, for 40 seconds one revolution is completed, and the total time is given as 2 minutes 20 seconds. That is 2 into 60 plus 20, the total time becomes 140 seconds. So for 140 seconds, the number of revolutions is assumed as n. So to find out that number of revolutions, we can use for 40 seconds 1 revolution, for 140 seconds n revolution. By cross multiplying it, you can get n is equal to 140 by 40, that is equal to 3.5 revolutions. So now the angle is assumed as theta, that is equal to 3.5 into 360 degrees, because one revolution is taken as 360 degrees. So the total angle is 1260 degrees. Then we can find out angle. Then we can use displacement formula, that is S is equal to 2r sine theta by 2. Then by substituting the angle, you can get S is equal to 2r sine 1260 by 2, that is equal to 2r sine 630 degrees. And that 630 degrees is changed as 360 degrees plus 270 degrees. Then you can get S is equal to 2r sine 360 degrees plus 270 degrees, that is equal to 2r sine 270 degrees. And again that 270 degrees can be changed as 180 degrees plus 90 degrees. Therefore S is equal to 2r sine 180 degrees plus 90 degrees, that is equal to 2r into minus sine 90 degrees, because sine of 180 plus theta is equal to minus sine theta. Based on that, we can get S is equal to 2r into minus sine 90 degrees, that is equal to minus 2r. So the magnitude of displacement in this case is taken as S is equal to 2r. And next one, based on the displacement of another problem, that is question 4. Figure given here shows the displacement time graph for a particle. Is it practically possible? Explain. So observe the diagram. So the diagram is like this. So by observing this diagram, you can have one idea, that is at any instant of time the particle possesses two displacements, which is impossible. Therefore that graph is not practically possible. And next one more problem related to displacement, that is a wheel of radius 1 meter rolls forward of a revolution on a horizontal ground. The magnitude of the displacement of the point of the wheel initially in contact with the ground is, and the options are given as option A 2 pi, option B root 2 pi, option C root pi square plus 4, and option D pi. So to find out the displacement in this situation, first we can assume that a wheel is there on the horizontal road, and A1 is the required point which is in contact with the ground, and if that wheel rolls of revolution, then the center of mass traveling by a distance pi r, that is denoted by A1b, and in this situation the contact point on the ground is going to A2. So that means the initial point is A1 and the final point is A2. So according to the displacement definition, the shortest distance between initial and final points in particular direction is known as displacement. So based on that displacement definition, A1 A2 length gives the displacement. So to find out that A1 A2 length or displacement magnitude, we can use A1 A2B triangle. So since it is right angle triangle, then the displacement S is equal to root of pi r whole square plus 2r whole square, that is equal to r into root of pi square plus 4. And in this case the radius of the wheel is given as 1 meter. Therefore the displacement magnitude in this situation is taken as a root of pi square plus 4. That means option C is correct. And next one, another problem related to the displacement. A person moves 30 meter north and then 20 meter towards east and finally 30 root 2 meter in southwest direction. The displacement of the person from the origin will be, and options are given as option A 10 meter along north, option B 10 meter along south, option C 10 meter along west, and option D 0. So to solve this displacement problem, first of all we know the directions, and the directions are given below, and in that diagram east, west, north and south directions are given, and the intersection point is assumed as origin, and east direction is assumed as positive x-axis, west direction is assumed as negative x-axis, and north direction is taken as positive y-axis, south direction is assumed as negative y-axis. And based on the position vector concept, the displacement can be written in vector form as S bar is equal to 30 j cap, because initially the person is traveling along north direction, plus 20 I cap. It is due to the movement of the person in east direction by 20 meters. And next one, 30 root 2 along southwest direction. So the displacement along southwest direction is taken into components, and that direction makes 45 degrees with west direction or south direction. So by taking the components, you can get 30 root 2 cos 45 degrees minus j cap plus 30 root 2 sin 45 degrees minus I cap. Then by expanding this, you can get S bar is equal to 30 j cap plus 20 I cap minus 30 j cap minus 30 I cap. So here 30 j cap minus 30 j cap cancelled. Finally, you can get S bar is equal to minus 10 I cap, that is equal to 10 into minus I cap. Minus I cap indicates west direction. Therefore, the displacement S is equal to 10 meter along west. So the option D is correct. And next one, based on displacement and distance concept, that means combinedly distance and displacement, we can give some problems. And that question is the numerical ratio of distance to displacement is. Options are given as option A always equal to 1, option B always less than 1, option C always greater than 1, and option D equal to or more than 1. So in this case, if the body is traveling along a straight line, in that case distance is equal to displacement. So in that case distance by displacement is equal to 1. If the body is traveling along a curved path, in that case distance is greater than displacement. That implies distance by displacement is greater than 1. And in this case, the path is not clearly mentioned. So due to that reason, the ratio of distance to displacement is taken as greater than or equal to 1. Therefore, the option D is correct. And next one more question based on the distance and displacement combinedly, that is a person moves towards east for 3 meter, then towards north 4 meter, and then moves vertically up by 5 meter. What is his distance and displacement from the starting point? So first we concentrate on the distance. So distance means the length of the actual path. So therefore the distance D is equal to sum of all the distances, that is D is equal to 3 plus 4 plus 5, that is equal to 12 meters. Next we concentrate on displacement, and in this case also the east direction is taken as x-axis. Therefore along east direction the displacement is taken as 3 I cap, and north direction is taken as y direction. Therefore the second displacement is taken as 4 j cap. And next one, 5 meters in vertically upwards direction, that upwards direction is taken as z direction. Therefore the third displacement is taken as 5 k cap. Therefore the displacement in vector notation finally is taken as S bar is equal to 3 I cap plus 4 j cap plus 5 k cap, and the magnitude of the displacement can be taken as S is equal to root of 3 square plus 4 square plus 5 square, that is equal to root of 9 plus 16 plus 25. That implies S is equal to 5 root 2 meters. And the next problem, it is also based on the distance and displacement combinedly. A particle moves in a circle of radius r in half the period of revolution find its displacement and distance covered. So to find out displacement or distance, we know about formulas. For distance in circular path, formula is given as distance is equal to r theta, and displacement is taken as s is equal to 2r sin theta by 2. Both the formula we can use. So to find out that distance or displacement, first angle is needed. So here half revolution is completed. Since half revolution is completed means the angle is taken as pi radians. For full revolution 2 pi radians, for half revolution pi radian. So the distance is taken as a distance equal to r theta, that is equal to r pi, that is equal to pi r. Next one, displacement s is 2r sin theta by 2, that is equal to 2r sin pi by 2, that is equal to 2r, because sin pi by 2 is taken as 1. That is about this problem. Next one, question 10. A particle is moving along a circle such that it completes one revolution in 40 seconds. In 2 minutes 20 seconds, find the ratio of magnitude of displacement and distance. The options are given as option A 0, option B 1 by 7, option C 2 by 7, and option D 1 by 11. So to solve the ratio of displacement and distance, first step, it is traveling in circular path, therefore you know about displacement formula, that is 2r sin theta by 2, and distance formula r theta. That means first of all we know about angle. So to find out that angle, we can use the given data. So first we can find out number of revolutions. So to find out number of revolution, we can use the total time. The total time given as t is equal to 2 minutes 20 seconds. Therefore the total time t is equal to 2 into 60 plus 20, that is equal to 140 seconds. So for finding of number of revolutions, we can use the formula n is equal to 140 by 40, that is equal to 7 by 2. So it is taken by using the given data as for 40 seconds one revolution is completed, and for 140 seconds how many revolutions completed, that how many is taken as n. By cross multiplying you can get n is equal to 140 by 40, that is equal to 7 by 2. So after getting the number of revolutions, now you concentrate on the angle. So for one revolution the angle is 2 pi. For 7 by 2 revolution, the angle is taken as theta is equal to 7 by 2 into 2 pi, that is equal to 7 pi radian. Now by knowing this angle we can find out a distance. Distance general formula in circular path is taken as t is equal to r theta. By applying theta equal to 7 pi, you can get d is equal to 7 r pi. And after that, d is equal to 7 r into pi is taken as 22 by 7. So you can get d is equal to 22 r. Next one, the displacement s. General formula s is equal to 2r sin theta by 2, and theta is taken as 7 pi here. Therefore s is equal to 2r sin 7 pi by 2, and that 7 pi by 2 can be written as 2 pi plus 3 pi by 2. Therefore s is equal to 2r sin into 2 pi plus 3 pi by 2, and it can be changed as s is equal to 2r sin 3 pi by 2, and that is equal to minus 2r. So the magnitude of displacement is equal to 2r. Then they are asking the ratio of magnitude of displacement and distance. So the magnitude of displacement and distance is equal to 2r by 22r, that is equal to 1 by 11. So that implies the option D is correct. So this is about this session, and next we can explain about speed and velocity. So this is about this session. Thank you.